Hello, physics, electric fields. The problem is two charges minus q and minus 3q are a distance L apart. What be the charge and placement of the third charge particle so that it experience no effect and no net force? So this is a charge particle, this is another charge particle, this is minus q, this is minus 3q. The distance is in between is L. So L distance apart. So L is the separation. Another charge particle which is positive q, because these two have repulsive force, it will be uh, so we have another particle which is positive charge, so it is x distance away from this end, x distance away, and this distance is L minus x distance. So L minus x distance. So here there is no force. It's a no force. So then we can have a force on minus q naught and this one, and then we have force on this one. So force on minus q naught. So that will be this one and on this one. So this will be k q naught q over x square. That should be equal to the force between this and this. So k q naught 3q naught over whole L square. So because q naught experience no force, q naught experience no force. So force on minus 3q naught. So this one, because this and because of this, so this will be k minus 3q naught into q over L minus x whole square is equal to this and this, k 3q naught and q naught into L square. This is 1, this is 2, this is 3, this is 4. 2 and 4 are equal. That means we can use these two terms. So 1 and 3. 1 and 3. So kq naught q over x square is equal to k 3q naught q over L minus x whole square. K cancel, q naught cancel. So we will get q cancel, only this 3 is remaining. So this will be L minus x whole square is equal to 3x square root of the whole term. So that will be L minus x is equal to square root 3 into x. This will go on this side. So L is equal to x common. So 3 square root plus 1. So x is equal to L over 3 square root plus 1, or x is equal to, if you solve this one, this is equal to 0.3, 36%, 366 L. So this is the value of this one. So now we have to find the value of q, q naught. So we can still use this one from here, 1 2. So 1 and 2, k q naught into q over x square is equal to k q naught 3q naught over L square. K Q naught cancel. So from here, if you cross multiply, Q L square is equal to 3Q naught into X square, or Q naught is equal to Q L square over 3x square. 3x square is equal to, okay, and now we can substitute the value of L square. So this is equal to Q over 3x square. L square is this one, so substitute this value. So L square is equal to x into 3 square root plus 1 whole square. So equation this one. So this is equal to Q over 3x square. This is x square into square root 3 plus 1 whole square. This x square cancel. So this is equal to q over 3 into 3 square root plus 1 whole square, which is equal to q naught. So we can say q naught is equal to 3 square root plus 1 whole square divided by 3 into q, or q naught is equal to 0.402 q. So this is the answer. This is slightly complicated, but this is a beautiful question. Two charges, minus q, and don't be confused with the minus. So it's just to tell you that there is a repulsive force. If it is a repulsive force, you have to use the particle with the opposite polarity. So these are the two negative, we have to use positive. And then it have experienced no force. So the force on this particle minus q naught, and force on the minus 3 q naught. So force on the left hand, and then force on right hand, and then compare. So then we will be able to solve this equation correctly.